Section 5.6, solving exponential and logarithmic equations. A lot of the stuff that you've been doing is going to play into this, and these are going to be kind of review for you. They're not going to be too hard. Before we start, we do need to clear this up. It says, before we start solving equations, keep in mind the following facts concerning logarithms and exponents. If you've got some number to the u power, and it's equal to that same number to the v power, let me give you an example of that. If I say 3 to the 4th power equals 3 to the what power, obviously it would be 4th power. That seems really simple, but you'd be really surprised. So if you're solving the equation 3 to the x power equals 3 to the 4th power, x must be 4. That's the only thing that makes that true. Same thing with logarithms. If you have the log of u equals the log of v, then u must be v. Again, what that means is if I say, okay, the log of 3 must equal the log of 3. So if you're given the equation, the log of x equals the log of 4, then x must be 4. You can dump the logs. The logs have absolutely no importance to that. The log of this equals the log of that, then this must be that. If you've got log, now you've got to be careful though. If I say the log of 3 equals x, you can't do that. You can't say x is 3. Log stuff equals log stuff, drop the logs. But if I say the log of 3 equals log of x, then obviously, what could I put in the place of x to make that the same? 3. Okay, I know that seems very common sense, but that's a lot of the lesson is based on that. Log stuff equals log stuff. We can use this fact in our first example to very quickly solve the equation, but that doesn't look the same, does it? 27 to the x plus 3 equals 3 to the what? X. Again, the only time you can use the shortcut I just showed you is when you have like 3 to the 5th power equals 3 to the what power. The bases have to be the same. But 27 and 3 is not the same, right? Could I make them the same? Sure. 27 is the same thing as 3 to what power? 3 to the 3rd. 3 times 3 times 3 is 27. Take out the 27 and put 3 to the 3rd power. But the problem is you got 2 powers now. Put that in parentheses. A power to a power, what do you do with them? You multiply. Power raised to another power, you multiply. So 27 to this power is 3 to the 3rd to this power is 3 to the 3x plus 9 power. Okay, now let's use that whole common sense stuff that everybody looked at me funny for. If 3 to this power equals 3 to this power, then obviously 3x plus 9 must equal x. And then you just solve it. 2x is negative 9. X is negative 4.5. Any questions? Okay, here we go. Next problem. That was example 1. It says, since we can't always make the bases equal, we have to have another method. And this method would work for that problem as well. These steps will be demonstrated in the following examples. 3 to the x power equals 12. Let's talk about the difference between this problem and the one we just worked. Can you take 12 and write that as 3 to some power? No. Because 3 to the 2nd is 9, 3 to the 3rd is 27. Can't do it. So we have to have another method of solving these equations. Let me show you the easy way of doing it. The easy way of solving this type of equation is to rewrite it as a logarithm. How do you do that? Log base of equals, makes sense. Type that in your calculator. How do you type in log base 3 of 12? Log of, and that'll give you your answer. Somebody type that in, tell me what it is. Should be between 2 and 3. 2.26. Yeah, base is always on bottom. Yeah, that's what I think of it. Just like it is here. Yeah, it's like this. It's the bottom. It's the base. There you go. So 3 to the 2.26 power should equal 12, and you can plug that in and check it. Next problem. Says 2 to the 3x plus 2 equals 3 to the 2 minus x. This is a little bit tougher because how in the world do you write that as a log? Right? Let me show you. You're going to do log of base 2. Okay, if I use this as my base, the log of base 2 of this stuff, right, equals what? Stop, let it soak in. There you go. Log base 2 of 3 to the 2 minus x equals 3 to the x minus 2. But I've still got, some nasty looking stuff. But do you remember your power rule? What can I do with 2 minus x? You can move it down front. 2 minus x times log base 2 of 3 equals 3x plus 2. Any questions so far? What I would do here is go ahead and find log base 2 of 3. Y'all do that? You could divide by that 2 minus x if you wanted to, but you're going to have to move it back over. Find log base 2 of 3. So you do log of 3 divided by log of 2 to do that. Log 3 divided by log 2. Okay, leave that on your calculator. I would store that somewhere in my calculator, which I should have pulled it up and done on my calculator to kind of model it. I'll show you. Let's see, second quit, I've got to do log 3 divided by log 2. Log 3 divided by log 2. Enter. 1.58. Use your store key. We're going to do store into STO. Oops. It's right above the on key. STO with an arrow. Store into alpha, wherever you want to store it. We'll store it in A. So now anytime you want to use STO, alpha A. So anytime, STO, right there. Alpha, green button, and then whichever letter you want to store it. So now anytime you want to use that number, it's in A. There it is in A. If I want to do 2 times that, you can do 2 times A. Makes sense. So now, to work this problem, again, I put this in alpha A. We got a distributive property, so we got to do 2 times that, which, well, actually I just did. So about 3.17 minus 1.58x equals 3x plus 2. Okay, stop and let me explain what I just did. Log base 2 of 3 was equal to, what did we say, 1.58, right about. So I used distributive property. Just because it wasn't in front of the parentheses doesn't matter, you're still distributing. I did alpha A times the 2, and I did alpha A times the x and got minus 1.58x equals 3x plus 2. Now it's linear. Let's move our x's to the same side. So, and at the same time, we're going to move, we'll combine steps and move our 2 over here. So how many x's we're going to have? We're going to have 3 x's plus the 4.58 x, and we've got to move the 2 over here and do minus 2. It would be 1.17. If you want a good exact answer, instead of using just plain old 1.17 and 4.58, you can use those stored values in your calculator. That's what I was trying to get at. No, you're adding x's. 1 apple plus 2 apples instead of 3 apples squared. If you're adding them, just plain old x. So we're doing, I'm just going to do regular 4.58 divided by 1.17, enter, 3.91. You can check yourself on these. And let me, since this is such a complicated one, let me show you how to check it. Because good possibility we might have missed some part. If we think x is 3.91, you can go up here and plug it into each of them. 2 to the 3 times 3.91 plus 2 should equal 3 raised to the 2 minus 3.91. So do each part just to check it and just see if they are equal. So you've got 2 raised to the 3 times 3.91 plus 2. You get about 13,587. 3 equals 6x. You divide by 6, so you're dividing by 4.58. 1.17 divided by 4. Did I divide it wrong? I'm sorry. I think I did. I believe you're right. Yeah, 1.17 divided by, thank you, I'm glad you caught that, 0.255. My bad. Yeah, too bad we were checking that. Goodness, Morgan, why didn't you tell me that sooner? See there, yeah, I was testing you. I was going to show you that if we checked that, we'd come up with the wrong answer, so obviously we missed something, so we was going to go back and we was going to check it there. Now that's fine. We'll take that. So here we go. 2 raised to the 3 times 0.255 plus 2. Enter. That looks better. 6.70 or 6.80. And on the left side, or right side, excuse me, you got 3 raised to the 2 minus 0.255. It's not going to be exact. Well, actually, that was pretty close. But you can check yourself to make sure it does equal out on both sides. And it would have been a decimal. You're right. I didn't even notice. So here we go. Example 3. Solve the following equations, and notice the hint I gave you is